So solving compound linear inequalities is a little more complicated than just solving the basic ones. We need to be aware of a few situations. The first two examples are going to talk about the intersection and union. So you got to remember that intersection can be replaced with the word and mathematically we use the intersection symbol, which is that upside down U shape. The union could be replaced with the word or, and mathematically we use that U-shape union symbol. So let's take a look at union first. So examples. So we want to solve, and we want interval notation for our final answers. And we're going to be seeing some graphs and whatnot too, just because it ends up being easier to get a grasp of what things should look like. So even if you're not asked to provide a graph, you might actually want to use graphs just because they make things nicer. So let's look at example 1. Let's look at 2x plus 1 is less than -3, and 5x is less or equal to 10. And I want or to be the statement in between. Okay, so if I'm asked to solve this statement, sometimes you might see people put curly brackets around the equation or the inequalities, and that's fine. That just means it's a set. You might actually see this. 2x plus 1 is less than -3, or 5x is less than or equal to 10. And it doesn't matter what's inside the brackets or how it's written, we're going to treat each one of these inequalities separately. We're going to solve them, and then we're going to try to combine things at the end. Okay, so there's different ways you can see this. Again, the word or and the union symbol are interchangeable. So let's solve the first inequality. I have 2x plus 1 is less than -3. And if I want to get x by itself, I have to subtract 1 from both sides. So 2x plus 1 minus 1 is less than -3 minus 1. And I'm going to get 2x is less than -4. Be careful with your signs there. Dividing everything by 2. 2x divided by 2 is less than -4 divided by 2. And x is less than -2. And we'll handle the graphs after I solve that other one. So I have 5x is less than or equal to 10, dividing everything by 5. And I have x is less than or equal to 2. So I want to find out what these two things look like when they're added together. And so I have x is less than or equal to 2. And that looks like this. Let me use my highlighter and make sure I indicate that 2 is there. And the other one is x is less than -2. And let's use my highlighter. I'm going to use blue for that one. So to make sure everything's abundantly clear, let's highlight everything accordingly. And if you remember, I want to find out what happens when I add these two sets together. So let's superimpose. So I'm going to have that one there, -2, 2, yellow, blue, and I want to know if elements are in one or the other or both. And it doesn't matter if they're in both, we don't write it twice. So basically, I'm going to look for everything that's shaded, and I don't even care what color it is. That's the easier way to think about it. Is when you're talking about the union or you're going to look for everything that's shaded, and it doesn't matter if it's overlapping or not. If it's shaded, it gets written down. And so basically this is x is less than -2 joined with x is less than or equal to 2. If you want to write things complicated, but we can simplify this because these things overlap. I'm looking at x to the left of, x to the left of. Really, everything boils down to x. Oops. X is less than or equal to 2, because -2 is also less than or equal to 2. And so our interval would be -infinity to 2. So when you're solving the union, if you think about things of just take it if it's shaded, it actually becomes a lot easier. This answer that I've written right here that I'm going to underline in green is technically correct, but it's not simplified. So we can simplify these by trying to omit the overlap and just take everything that we care about. Let's look at another example. Let's look at 3x plus 1 is bigger than -5, and -2x is less than or equal to 10. Again, we're going to solve these one at a time. So 3x plus 1 minus 1 is bigger than -5 minus 1. 3x is bigger than -6. Dividing everything by 3, I'm going to get x is bigger than -2, which is pretty much the same thing we got on that last one for the first inequality. Now let's look at -2x is less than or equal to 10. -2x is less than or equal to 10. -2x divided by -2 is bigger than or equal to 10 over -2. We have to change the inequality sign there because we're dividing by -2. And finally, I'm going to get x is bigger than or equal to -5. And if I'm going to graph these, x is bigger than -2. And let's shade that. And I want to look at, let's see here, -5. And that's going to be to the right of, I'm going to shade that. If I were to try to superimpose those, -5 is to the left of -2. So I'm going to get -5, -2. And let's do my shading. And with the intersection, we're going to look for the overlap. And in this case, it's stuff that shows up in green because yellow and blue make green. And the intersection would be -5 to infinity, intersect with -2 to infinity. And that's going to give me -2 to infinity. And because the green is everything that is overlapping, we're not allowed to attain -2 in our first set. And it has to be able to show up in both. So we're not going to include -2, but everything to the right of 2 shows up in both sets. So this is going to be our final answer. So when we have union and intersection, we're going to treat each inequality as one, and then we're going to combine them at the end. And the other type of inequality that you're going to see is a compound inequality where it has two inequality symbols. So recall, if I have A less than X less than B, that A has to be less than B. These only can go in one direction. We could also write B is bigger than X is bigger than A. It doesn't really matter as long as the logic flows. So let's take a look at a third example. And let's look at -1 is less than 2 times x minus 5 is less than 7. So just to make sure, this -1 is less than 7. And my inequality symbols are making sense because they're going in the correct direction. We need to isolate the variable here. So what I'm going to do first is I'm going to distribute this 2 over the x minus 5 to get rid of my parentheses. And I'm going to get -1 is less than 2x minus 10 is less than 7. The values on either end didn't change because I didn't do anything to them yet. And I want to isolate my variable here. So I'm going to get x by itself, and I'm going to need to undo the order of operations. So let's add 10 to each part. So since there's 2 inequality symbols here, there are 3 parts to this inequality statement. It's a compound statement. So I'm going to add 10 to each part. If I add 10 to each part and clean up, I'm going to get 9 is less than 2x is less than 17. And to get x by itself, we have to divide everything by 2. So let's divide each part by 2. 9 divided by 2 is less than 2x divided by 2 is less than 17 divided by 2. And that gives me 9 halves is less than x is less than 17 halves. And fractions are perfectly legitimate for endpoints here. And since we're dealing with a number line that we're not really making all kinds of tick marks on, all I care about is 9 halves is less than 17 halves. And so I'm shading everything in between because x has to be between those values, and that's what these inequality symbols say. And that gives me the solution set of 9 halves to 17 halves. So we solved the compound inequality that had 2 inequality symbols. It doesn't matter if they're less than or equal to, as long as they're facing the same direction, everything makes sense. We do have to multiply, or we do have to flip the inequality symbols if we multiply or divide by a negative. Let's look at one real quick example. So the last example is going to be a little bit easier than that last one. Let's look at 2 is less than or equal to -4x is less than 8. So this 2 is less than or equal to -4x is less than 8 makes sense. Even though there's a negative sign here, that's a variable. So that can change. So we're not too worried about what's going on there. I'm worried about 2 being less than 8, and that is true. So in order to solve this, I'm going to have to divide everything by -4. So 2 divided by -4 is bigger than or equal to -4x divided by -4 is bigger than 8 divided by -4. And both of my inequality symbols changed here. And that is absolutely necessary because I divided everything by a negative. It's going to be -1/2 less than or equal to x is less than -2. And -1/2 is bigger than -2. So I'm doing this little mental check here to make sure that my inequality symbols are making sense. And we should always be doing that just to make sure we're keeping track of what's going on. And a lot of people are going to struggle, myself included. I like things to be opening up the other way. So let's take this whole thing and turn it around. So if I'm looking at my inequality, this symbol is pointing at the -2 and opening up toward the x. This symbol is pointing at the -2, opening up toward the x. All right. My bigger than or equal to, less than or equal to. Again, this is pointing to the x and opening up toward the -1/2, pointing toward the x, opening up toward the -1/2. You might remember people putting teeth in there, saying it wants to eat the bigger thing. Whatever you need to do to make that work for you is fine. So now that I have this written in a way that I'm going to be more comfortable with graphing, -2 is on the left of -1/2. -2, -1/2. And let's see here. That's going to open up that way with a round parenthesis, and that's going to open up that way with a closed bracket. And I'm going to shade everything in between. And my interval notation is going to be -2 to -1/2. And this is the interval solution for that particular problem. So rules haven't changed. When we solve inequalities, this one had two inequality statements in 3 parts, which means everything had to be divided by -2. So it meant that I have to divide -2, divide by -2 3 times over. And there we go.